morning, student. Welcome our channel, the one and only physics point. And in the previous lectures, we have started discussions of the new points, new concept, that is new chapter. The name of the chapter is heat. And today, in these lectures, we have started discussions of the anomalous behavior of waters. Water shows us some different properties as compared to other, as the other substance, other liquid shows, they have shown the different properties. When we are heating any substance, they get expand, and cooling any substance, they are contract. But water shows the different behaviors in between some range of the temperature from the 0 degree Celsius to 4 degree Celsius. They doesn't follow the rules or the any behavior as all liquids are shows. Then the study of anomalous behavior. Please take the heading, that is anomalous behavior of water. As every liquids or other substances or liquids which can be contract when cooling and expand when heating, but water does not show that types of the reactions or that type of the behaviors in the range of the temperature from the 0 degree Celsius to the 4 degree Celsius. This behavior is called as the anomalous behavior of waters. And these anomalous behaviors of water studied by one of the experiment, one of the apparatus. This apparatus is known as Hope's apparatus. Then in these lectures we are just studying and construction and working of the Hope apparatus as well as proof of the anomalous behavior of water. The first, the liquid substance, the liquid substance are expand when heating at certain temperature and get contract when cooling. When cooling, but the water does not contract when it cooling and does not expand when it is heating. When the water is heating, the water shows different properties, different or opposite property, different properties in the range of temperature, the range of temperature between 0 degree Celsius to 4 degree Celsius. When it heating from 0 degree Celsius to 4 degree Celsius, every substance gets expand, but waters are contract. At the time of heating from 0 degree Celsius to 4 degree Celsius, water gets, if every substance gets expand, but water is contract. Water gets contract. At the time of at cooling from 4 degrees Celsius to 0 degrees Celsius, the water gets expand, and it shows the similar properties as of another liquid between above the 4 degrees Celsius and below the 0 degrees Celsius. The water shows the similar properties of the other liquid substance in the in different range or outside of that range at 4 degrees Celsius to 0 degrees Celsius or 0 degrees Celsius to 4 degrees Celsius. When water gets cooling less than 0 degrees Celsius, it gets contract. When water is heating above the 4 degrees Celsius, it gets be expand or it expand. This is shows the as similar properties of the other substance, but water doesn't shows the properties of expansion and contractions in the range of 0 degrees Celsius to 4 degrees Celsius. This is called as the anomalous behavior of water. This is called anomalous behavior behavior. Anomalous behavior of water. Then we start to study the anomalous behavior of water in with the help of some experiment that is called as Hope's apparatus. Hope's apparatus. Let's draw this construction and working of the Hope's apparatus. Before we go to study the Hope apparatus, just revise the anomalous behavior of the water. The liquid substances are expand when it is heating at certain temperature and gets contract when it is cooling. This is the normal behavior of every liquid substance, but the water shows the different properties in the range of temperature from the 0 degrees Celsius to the 4 degrees Celsius at the heating. While heating from 0 degrees Celsius to 4 degrees Celsius, every substance gets expand, but water is a contract. At the time of cooling from the 4 degrees Celsius to 0 degrees Celsius, every substance gets contract, but water gets expand. This behavior is called as the anomalous behavior of water. This anomalous behavior of water are studied with the help of one apparatus or one instrument. This instrument is called as Hope's instruments or Hope's apparatus. First, construction, function, working of the Hope's apparatus, and we can study the anomalous behavior of water with some graphs as well as diagrams. We take one of the cylinder, water cylinder or liquid cylinders like this. It is the liquid cylinder which is filled by water, and surrounding to that liquid cylinder we put surrounding to that liquid cylinder we can take a flat bowls. Surrounding to that liquid cylinder we take a flat bowls, and these flat bowls are contain the freezing mixture. The freezing mixtures are the mixture of salt and ice, and these freezing mixtures are also this is the Hope's apparatus. We take one of the cylinders which are filled by the waters and the flat bowls which are surrounding to that cylinders which are filled by the waters, and these flat bowls are contained or filled by a freezing mixture or cooling mixture. These freezing mixtures are mixture of salt and ice, and the two thermometers are connected above the freezing mixtures which can be measure the temperature T2, and below the freezing mixture which is measure the temperature T1. There are two thermometers are connected above and below for measure the temperatures of water which are inside the cylinder above the freezing mixture and below the freezing mixture. Temperature T1 is the below the freezing mixture of waters. Temperature T1 the temperature of water below the freezing mixture, and temperature T2 is the temperature of waters which are above the freezing mixture. Just write the construction. Construction of Hope's apparatus. The first point will be a cylinder which is filled by the water. The cylindrical plot, the cylinder which is filled by water. The cylinder which is filled by the waters, and the flat bowls or flat bowl surrounding to the water cylinder, surrounding to the water cylinder which contain freezing mixture. freezing mixture. It is the mixture of ice and freezing mixture is the mixture of ice and salt. There are two thermometers are connected above and below the freezing mixture or the flat bowls which are trying to measure the temperature of the waters above the freezing mixtures and below the freezing mixture. The two thermometer are above and below the above and below the freezing mixture, above and below the freezing mixture, which is measure the temperature of water. The thermometer measure the temperature of water measure the temperature of water, it is T2 above and T1 below the freezing mixture. These two thermometers, that is T2 which is measure the temperature of water inside the cylinder above the flat bowls or above the freezing mixtures, and T1 it measure the temperature. The another thermometer which is measure the temperature T1 below the flat bowls or freezing mixtures. What happens? Consider the initial temperatures of the waters inside the cylinders, which is the 50 degrees Celsius. Consider the initial temperature. Consider an initial temperature of water is 15 degrees Celsius. Then the T1 is must be equal to T2, that is equal to 15 degrees Celsius initially. Then water shows the normal behaviors in the range of the temperature which is outside of the 0 degree Celsius to 4 degree Celsius. If the range of the temperature is outside the 0 degree Celsius to 4 degree Celsius, the water shows the normal behavior as similar to the other liquids. But 15 degrees Celsius is more than 4 degrees Celsius, that means the water shows the normal behavior at the time of cooling. This cooling mixture is try to cool the liquids or try to cool the waters which are present inside the liquid cylinder or inside that cylinder. These freezing mixtures are trying to cool the temperatures. That means if the temperature is reduced 50, 14, 13, at that times the T1 which is below the freezing mixture, T1 is the temperature of the water which is below the freezing mixture, and T2 is the temperature of the water which are above the freezing mixtures. But at the time of cooling from 15 degrees Celsius to 4 degrees Celsius, these waters inside the cylinder gets contract. That means the T1 temperature T1, the T1 is more frequently reduced, more frequently reduced as compared to T2. At that times, when the water molecules inside the cylinder gets contract in between the 15 degrees Celsius to 4 degrees Celsius, that means it comes in downward directions. And the temperature T1 is more frequently reduced as compared to T2. If the T2 temperature is comes 15 to 14, at that time the temperature T1 is comes to 15 to 13, and this is more frequently reduced up to the 4 degrees Celsius, reduced as compared to T2. And at the time T1 is equal to 4 degrees Celsius, then it stop reducing. It stop reducing or decreasing. The temperature T1 is more fastly decreases from 15 degrees Celsius to 4 degrees Celsius. At the time of 4 degrees Celsius, the temperature T1 it stopped decreasing, and after that the T2 temperature is comes to decrease from the something degrees Celsius to 4 degrees Celsius. Again it's go to 0 degrees Celsius. Because in the range of 4 degrees Celsius to 0 degrees Celsius, water gets expand. That means these molecules which are 4 degrees Celsius, it again gets cooling. After the cooling of water molecules after the 4 degrees Celsius that gets expand. If they expand, the volume of the water molecules is increased. If the volume is increased, the density of the water is decreased. If the density of the water molecule is decreased, they move above. And at that time, the T2 is comes up to the 4 degrees Celsius to 0 degrees Celsius first. The T2 temperature comes 4 degrees Celsius to 0 degrees Celsius first, then T1 gets a decrease. This is the constructions of the Hope's apparatus. Now, the main working of Hope's apparatus. Then main working. Then the T1 equal to 4 degrees Celsius. Then T2 is reduced up to 0 degrees Celsius. T1, when T1 is a 4 degrees Celsius, T1 is reached at the 4 degrees Celsius, then T2 again decreasing up to the 0 degrees Celsius. Then the water on the above surface or water at the T2 start freezing. The water at the above surface start to freezing. If the above surface are start to freezing, then these waters are continuously freezing. Then after T2 equal to 0 degrees Celsius or T2 reach at 0 degrees Celsius, then T1 is decreasing up to 0 degrees Celsius or so on. Again, it is trying to less than the 0 degrees Celsius and whole water in that cylinder gets a freeze. This is the function and constructions of the Hope's apparatus. Initially, the both temperature T1 and T2 are same because the water is in the normal conditions. The freezing mixtures is try to freeze the liquids or reduce the temperatures of the waters inside the cylinders. At that times, from the 15 degrees Celsius, we are assume the 15 degrees Celsius of the temperature of water at the initially. That times, then it is trying to freeze. Then 15 degrees Celsius to 4 degrees Celsius, the temperature of the waters gets decreases. At that time, it is cooling, but the water shows the anomalous behavior between the 0 degrees Celsius to 4 degrees Celsius. But above the 4 degrees Celsius or below the 0 degrees Celsius, the water shows the normal behaviors as all substances shows. And 15 degrees Celsius to 4 degrees Celsius, the water are contract at the time of cooling. If they are contract, that means the water molecules have the more dense as compared to other. That means they follow downward directions or they falls on the downward direction. That means the T1 temperature is more frequently decreasing as compared to T2. At the time of 4 degrees Celsius, when the T1 is reaches the 4 degrees Celsius, at that time T2 is gets reduced from 4 degrees Celsius to 0 degrees Celsius. After the freezing above surface of water, after the freezing of above surface of water, then the T1 gets decrease and whole water gets freeze. The first surface water will be freezing. Then let's plot one of the graph here, which is the graph in between the volume and temperature. The y-axis which shows the volume of water, and x-axis which is the temperature, the 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, 4 degrees Celsius, 5 degrees Celsius, 6 degrees Celsius. This is the temperature on x-axis, and y-axis this is the volume, that is 1000, 1000.10, that is 1000.20, 1000.30, 1000.40. When the water is heating, it contract between the 0 degree Celsius to 4 degree Celsius. That means it shows like that. At the time, at the temperature 4 degrees Celsius, the volume of the water is more and more less. The density of the water is more at the 4 degrees Celsius. After above the 4 degrees Celsius, the temperature increase, then the volume is must be increased. This is a graph which shows the anomalous behavior of waters, that which is the volume and temperature graph. The volume of water between the 0 degree Celsius to 4 degree Celsius is try to contract at the time of heating. After the 4 degree Celsius, it again expand. Then the temperature range between, or the reducing temperature of T1 and T2, which is again shown with the help of one graphs, temperature and time. On the y-axis, which shows the temperature of waters inside the hope cylinder, and on the x-axis which is shows the time, and on the y-axis which is the temperature. When we measure the temperature or taking the reading of T1 and T2 temperature from every 5 minutes, which is shows some different reading, that is 2, 4, 6, 8, 10, 12, 14 and 16. This is a 15. At the initially, that is 5, 10, 15, 20, 25 and 30 minutes. At the initially T1 and T2 both are same. I'll be use the yellow color for the T1 and pink color for the T2. Up to the 4 degrees Celsius, the T1 is more frequently reduced. T1 is the more frequently reduced up to the 4 degrees Celsius temperature. Then the T2 is slowly reduced up to the 4 degree Celsius. This is for a T2 and this is for a T1. Initially the temperature of water below the freezing mixture is more frequently decreasing as compared to the T2, which is above the freezing mixtures, and at that time the first T2 is reduced and T1 take the more time to comes 0. This is the behaviors of waters in the range of 0 degrees Celsius to 4 degrees Celsius. At the 0 degrees Celsius to 4 degrees Celsius, this is the cooling. At the time of cooling, water gets a contract. No. At the time of cooling, from 4 degrees Celsius to 0 degrees Celsius, which is expand, and above the 4 degrees Celsius or below the 0 degrees Celsius, it shows the normal behavior as the normal water will be shows. What happens? Consider it is an oceans or the ponds. Some aquatic animals are lived in the plants. What happens when the temperatures of the surrounding gets decreasing, continuously decreasing, what happens? If the temperatures of the surrounding is, or environment is continuously decreasing, at that time it work, the sponges work as similar to water which are present in the hoop cylinder. Then, when the temperature is less than 4 degrees Celsius, the waters which are present on the surface gets freeze. If they are converted into the ice, it is works as the heat resistance. Then heat could not be transferred, or cooling could not be transferred inside the waters. That's why the whole oceans or whole ponds does not freeze, can't be freeze. This is the useful anomalous behavior of water for the aquatic animals which are lives in the plants and something. Okay, thank you.